Hi everyone, this is Kalyan Kumar this side and welcome to Chemistry Universe. This is part 12 of amines, and with this video we're going to start, and for a couple of future videos we're going to be doing aniline in particular. Now, aniline, as you know, is also known as benzamine. Is basically a benzene ring having an NH2 group in it, and this is a primary amine. But since it is attached to an aromatic ring, there could be some differences between this primary amine and an aliphatic primary amine. So this is what we're going to explore in this and in the certain upcoming videos. Let's get on with this one. Okay, so let's start with aniline, and this is part 1 of aniline, that is preparation and physical properties. So this is what we're going to do in this. So first let's look at the preparation. The first is the lab method for preparation of aniline. This is very typical of primary amines. You take nitrobenzene, and you put tin and HCl, and then further with NaOH you will be getting aniline and water. So it's basic reduction. And there's no need to look at the mechanism into this. A similar method, which is the industrial method, uses iron instead of tin. So this is again nitrobenzene using iron HCl and then leaching it with the NaOH. You again get aniline and water. The next, I think we know a few set of reactions which give us primary amines. If you remember the Hoffmann, Bromamide, and similar type of reactions. So you take benzamide, add bromine, and we have done this in aliphatic amines also, KOH, and you'll get aniline and K2CO3, KBr, and water. A similar reaction will be the Schmidt reaction. The Schmidt reaction on benzoic acid, if you remember, we use hydrozoic acid with sulfuric acid and we get aniline. They all go through the same pathway of forming a nitrene, and then nitrene converted to isocyanate and then becoming the amine. We can have an isocyanide also converting it. So we use C6H5NC, benzene isocyanide. We do the hydrolysis and you get aniline in this, and the carbon goes as formic acid. And obviously we can do the hydrolysis of phenyl isocyanate. Isocyanate is one of the products of Schmidt and Hoffmann reaction. So you have NCO, and the hydrolysis of this would give us an amine. So that is the preparation of aniline. And if you look at the physical properties of aniline, pretty simple. Fresh aniline is a colorless oily liquid. And on standing, the color becomes dark brown due to the action of air and light. Basically, what happens is in the presence of air and light, the aniline forms the oxidized compounds of benzene. It forms quinone, and that is reddish brown in color. Its boiling point is 183 degrees Celsius, implying that at room temperature it's a liquid. And it is heavier than water. Due to hydrogen bonding, its solubility in water is there, but it's not heavily soluble. It has a characteristic unpleasant odor, and it is toxic in nature. Generally, compounds that are toxic in nature, generally they have an unpleasant smell. This is one of the byproducts of evolution. So anything that is unpleasant is generally toxic. So with that, we come to the end of this particular part of the video. That is the aniline part 1, which was preparation and physical properties. And in the further videos, we're going to do some more parts of aniline. We're going to see various reactions of aniline and certain other uses of aniline. And so till then, have a nice and wonderful day. And thank you for watching this.